Hello everyone and welcome to today's Softree webinar on site design and grading in terrain tools. For those of you here in the live version of the webinar, please ask questions and engage with us through the Q&A section of the GoToWebinar panel. We'll address all the questions at the end of the webinar. And just for reference, all question askers' identities remain confidential. For those of you in the future watching this off our YouTube channel, we do monitor your questions in the comment section below, so please ask away. Okay, so we want to keep our intro for today super simple. But before we get started, let's just clear up what software we're talking about. So our software is modular. We'll be working in the terrain module. This is one of the modules of our road edge software, but it's also available as a product on its own, and it's called Terrain Tools 3D or Terrain Tools Forestry. And on to the next slide. So in this webinar, we'll be exploring a variety of terrain functions that includes digital terrain modeling, contouring, volume and earthwork calculations, grading, visualization and report generation. And with that, let's get into it.
Thanks, Andy.
There we
go.
Okay,
you should be looking at my screen now, and I've got a terrain open here, which is a quarry, and I just generated a cut, and I generated a pile. They would normally be surveyed, of course, but I thought it would be fun to make them. So let's backtrack a little bit and start from scratch. So I've got a terrain here, and this terrain is created from survey data. A lot of 3D surfaces now are being created by LiDAR and drone data. This is old school. It was created with a total station probably, and it's got three-dimensional points. They're not exactly random. It looks like they were pretty careful about running back and forth and picking up enough points. And in addition to just simple points, there are break lines. So this line here down the edge of this access road is pretty steep. It's probably just for a bulldozer or an excavator to walk up. That is a break line, and you can tell it's a break line because the properties are set here. There's another break line in here, actually quite a few that are related to the existing road over here. You can see that all the linear road features are break lines, and this creek bottom is also a break line. Just to illustrate what happens if you don't have break lines, I'm going to turn them all off and rebuild this model. So let's do that. I'm going to select all my features by property, and I'm going to choose break line features. This is a pretty useful tool. One of the things that it's good for is finding crossing break lines. I'm just going to select all the break lines here. I'm going to turn off their property. Notice there's quite a few of them. Typical break lines are road edges, following of a creek or bottom of a creek, top of an embankment, bottom of an embankment, toe of a pile, edge of road. You get the idea. Let's turn those off, apply, and watch what happens to my surface if I rebuild. So here's the terrain modeling tool, generate. It does two things all at once. It generates the surface if this checkbox is turned on, and it also generates contours. I'm going to skip the contours for now. Let's just generate the surface and see what it looks like. Okay, so it doesn't look a whole lot different, but there are some artifacts. There is a classic crossing or missing break line artifact. The surface that's being generated is just going straight through that little piece of road. So it doesn't look like a road exactly anymore. It looks like a road with washouts in it. Similarly, this pile here, that's the pile top. And because the software is interpolating between a point over here and a point over here, the middle of the pile is just gone. It's just not rendered. And you're getting similar behavior on the edge of the bluff here and the edge of the road. This is a lot of you will probably be familiar with road surveys, and when you look down a road in 3D and you see these funny triangles going across your ditch, that's because there's no ditch break line. So you can see them here, and you can see them there, and oh, here's one that even goes right into the road. Okay, so that's what break lines are for. Now, can I just undo that? No, it doesn't look like it. After you do a terrain calculation, the undo gets cleared. I'm just going to reopen it. And now let's generate some contours. So if I didn't have any contours, it would look like this. And I'm going to generate the surface. Now this time I have all my break lines in there. It's going to make a good surface. To make contours, I choose the major and minor checkboxes here, and then just pick contour spacing. Labeling is optional. I suggest that you only turn on labeling when you're really sure you want it, because it depends on the scale. Let's just do some contours with labels on, and I'll demonstrate the problem. If you have this thing zoomed in too much, and you turn on contour labeling, it looks okay when you're zoomed in. You don't get too many labels. There's one, there's one. But when you zoom out, you can see we've just got way too many labels on that contour. Okay, so let's turn off labeling. I don't have to recalculate my triangles every time. And contour spacing. This is going to be fixed in version 10. We've already done it. So version 10 automatically figures out the start and end, and you can override it if you want to. But in the current version 9, you want to make sure that your interval start is a nice round number. So 1200, for example, means that I'm going to get 1210, 1220, 1230. It's not going to do 1205, 1215. This one's fine. It's 1 meter spacing, so that's good. And the range, too, you want to check that your range is inclusive of all the elevation. Okay, so there's my contours. Contours do not represent the surface. The surface is represented by triangles. Contours are cheap and easy to create. You can delete them and then recreate them later. What are the triangles? Let's take a look. So we create what's called a TIN model, triangular irregular network, and every point is a triangle vertex. Every 3D modeled point is a triangle vertex. So if I select, for example, my break line here, you can see that it's set up to be elevations on, modeled on. That means it becomes part of the surface. If I select another feature like well, I don't know if I have any draped ones. We'll talk about draped features later. But if I select a feature like the contour itself, well, the model is turned off. It has a well-defined elevation, the calculated elevation for the contour, but it's not part of the surface. Now let's make some things with the grading tool. Okay, I'm going to switch over to a different, actually I'm going to start with a whole new terrain. So we've looked at generating a surface, what break lines are for. I'm not going to talk about how you create a break line in your survey. That's a long topic, but suffice it to say they were created by the surveyor, really, and we just have to make sure they're connected and they work. Now I'm going to go over and illustrate the grading tool. Let's create a brand new terrain. And when you're doing a grading operation, you almost always start with an empty terrain, and then you put something in the background. So in this case, I'm going to put in a terrain. There it is, in the background. It's the same terrain, actually. It's got a different name. I can't see it. Why not? Well, let's zoom extents. There it is. Okay, so it's actually the same terrain, almost. You can see there's some stuff missing here, or added, whatever way you want to look at it. I'm going to put in a dam across this part of the creek and build a pond. So how would I make the surface that represents the dam? That's fill. And I'm going to choose this contour here. That's 1238 elevation. And I'm going to make a dam that goes across and will fill up that area with water. So I'm going to draw a feature that represents my dam. Let's call it dam top. And it's going to be a 3D feature because it's going to be part of a surface. And I'm going to draw it with the mouse. Now the mouse doesn't have elevations defined, so you have to type it in. So I'm going to type in 1238 and draw it with the mouse. So there's my 1238 contour. Let's start about there. And let's just draw a feature around like so and finish again on my 1238 contour. I think I can afford to go a little closer to the edge of the model. Oops, I made an extra point there. I don't want that one. Click to pick it up, hit the delete key there. Okay, so there's my dam top. Now, it is possible to grade a line, but it actually works better if you grade a polygon. So let's make a small polygon that represents the top of my dam. It's going to be flat. It's going to look like a little road so I can run my bobcat out there. Or if it was at a bigger scale, maybe I'd be dumping material off it, running dump trucks along. Anyway, to do that, I'm going to use this tool here. I'm going to buffer by 1 meter in both directions. This is just going to buffer to the side. This is going to do the ends as well. And same elevation. I don't want to change the elevation. There we go. Now that's actually 2 features, so let's just join them together. And it's going in the clockwise direction. You can tell because if I do Control N, it jumps along the feature in the clockwise direction. That's important for the next step. Now that thing's sitting at the right elevation. It hits the ground here and it hits the ground over there, but it's up in the air along here because it's higher than the ground surface. I'm going to grade it out to intersect with the ground. That's what this tool is all about. It grades the current feature, and you can choose to grade to an elevation or to a file. Now, I already put that file in the background, so it's easy, but I can actually use the browser to pick any file on my hard drive. And the file has to have a surface in it. We know this has a surface. We have to know which way to go. That's why clockwise is important. That means left is outward. Okay, I got that right. And that would be a cut. This would be a fill. Let's do 2:1 for my fill slope. And, oh, that's the wrong way around. There, 50%. Now, some of these segments are quite long, and I'm going to be creating these things called slope lines that go down to the ground. Let's do it without the slope line, see what happens, or without extra slope lines. It's going to create a boundary around it, tin boundary. I'm going to calculate the surface. When I calculate the surface, I want to make sure I include all triangles, and I don't need any contours. Finally, let's do the volume at the same time. There we go. Okay. Okay, I had a problem with the surface, with the polygons, and you can see that there's no slope lines on these long segments. So what I'm going to do is change that up. Okay, is this feature okay? Yeah, it looks okay. As long as the same feature is selected, you don't have to delete all these other features. You can just go but then regrade it, and it will remove the old ones and create new ones. So let's do that. Let's see. Grading. Let's interpolate and make a feature, a slope feature every 2 meters this time, and do it again. Now that's interesting. No surface polygon sound. Oh, I know why that is. Yeah. Anyway, this looks really good. This is the solution I wanted. Okay. The volumes were calculated using this checkbox, and I want to turn that off. That was just saved in my file, and I forgot about that. So now I can see that I've got a fill volume of 660 cubic meters and a cut volume of very small amount of material, which makes sense. Sometimes this is backwards. That would mean that I have the final surface set wrong. So that's better. Right, so there's my surface. Now I can play around with it if I want to. Let's say, okay, well, I want to move this out a little bit. So there's a couple of different ways to do it. But if you modify your feature in any way, you can just regrade it, and it'll get rid of all these grading features and recreate them. That's my 2 meter spacing there. These are called slope lines. What it's doing is it's grading down until it hits the surface, and then it's connecting up all the dots to make this thing called a SS or polygon boundary. That is set to a tin boundary, so there's no triangles outside of it. The surface is contained within that boundary. And I've got a good volume. Right, so I could go off and build this thing. I could export this to various file formats to go out and stake it, or I could make a 3D model. Let's see what it looks like in 3D. There we go. Now for my next exercise, I'm going to try and figure out how much water this little dam will hold. So let's save our dam. I've already got one on the hard drive here. I'm just going to call this one Demo Dam. So there's two things I need to calculate the water volume and the water surface. I need a surface that represents the water, and I also need a surface that represents the ground after the dam has already been built. So let's generate that surface. Call that a merged surface, and you create the merged surface from the original ground. And the first thing, when you're doing a merged surface, the first thing you really need to do, oops, I saved that in version 10. I was playing around with our new software. When you're creating a merged surface, the first thing you want to do is to save as, because if you change the surface, you don't want to mess up your original ground. So I'm going to use this naming here, naming convention, quarry plus dam. Oh, it already exists. Now I'm going to do my merge operation. Terrain modeling, merge. pick the file. So when I created the dam itself, called Demo Dam, that was completely on its own. There's nothing in there except the dam. The surface was in the background. Now I'm going to merge that dam into the original ground surface. Don't need to change any of the options, just bring it in. There is an option there to cut a hole instead of do the merge operation. Now, where did it go? There it is. Okay, and one step that's important, after you do a merge, you need to recalculate the surface. It's been deleted because of the merge operation. Okay, do I want contours for this? I think I'll skip them. And okay, so there's my new surface, and you can see it includes the dam. When the merge operation happened, it was very careful about maintaining the elevation of the old surface outside the dam. It did that by creating a feature here called a hull feature, which is a 3D breakline feature that was originally draped on the original ground. And then there's another one, hull destination, hull source. Okay, so there's some complexity there, but the software handles that for you. You don't have to think about it. Now I've got a surface that represents the dam, and I want to put some water in there. Okay, well, let's just save that. And I'm going to flip over to a brand new terrain. And I'm going to create the water surface. So this is not really a grading operation, but it's kind of the same quality. I'm going to start again with an empty terrain and just put something in the background. I'm going to put in the background the merged surface. And again, Zoom Extents will find it for me. There it is. There's my dam. Now let's put some water in there. So I'm going to create a new feature called water. And it's going to be a 3D feature because I want it to be a surface later. And now what elevation do I want to draw it at? Okay, you remember the dam was at 1238. Let's go down 2 decimeters. Okay, so I'm going to draw this at, instead of at 1238, I'll draw it at 1237.8. Well, the water's going to be up to the dam. I don't really have to be too accurate about this. I can just basically, anything back from the center of the dam. I'm going to put in a little glitch here just to illustrate what happens if you do that. And out to here. Now, you can see, oh, I forgot to put the contours in when I generated that thing, and I need them now. Okay, I'm just going to save this. It's going to be called water. And I'm going to flip back to the where is it? This one. Put my contours in. So I'm going to put in the same contour settings I had before, 1 meter spacing, skip the labeling. Okay, there we go. I did that so I could see this contour here, the 1238 contour. Now let's save that. And go back to the water. There we go. Okay, so I started drawing this feature called water, and now I can see, here's my 1238 contour. All I need to do is stay outside of that. If I go inside, well, the water's going to actually fill up to that contour or so, similar, close. So I just need to be outside of it. That will make a nice surface. It has a concavity in it here, So I should make it into a tin boundary so I don't get any triangles outside of the surface. And now let's generate the surface itself. I don't need contours, it's all one elevation. I do need to include all because I have a well-defined boundary. There's my surface. It's a trivial surface. Let's just look at it in 3D. It's flat. And I got a little piece sticking over the edge here. Let's calculate the volume now between the water and my merged surface. I think everything is set up correctly here. Oh, except that thing. That was turned on before when I opened my file. We don't want to use polygons. I'll show you that in a sec. And volume between two surfaces, go. Right. So there's lots of fill that's underneath the water. And there's some cut also that's above the water. And it's the correct volume. It doesn't look the same as, oh, of course, it's different from my original. I moved the dam. Anyway, around 900 cubic meters. And that would be exactly correct, except for this little bit here, because the surface there is actually over the edge of the dam. Where does the water hit the dam? Where does it hit the ground? Those are interesting features to know about. So I'm going to generate them. If you turn on this feature here, calculate intersection features, then it will find them for you. Okay, the volume hasn't changed. Still 869. But there is my water edge feature, this feature right here. And there's another one out here. Oh yeah, if there was water out here, that's where it would fill up to. But actually that's just an artifact of the way I drew the water surface. So I can delete that. I don't want it. This is my important feature. In fact, I don't really need this old feature at all. Let's just delete the water edge here and use this feature as my water surface. It's all at the same elevation because it's the intersection of a flat plane with the original ground. 1237.8, that's correct. And let's make it into a tin boundary. Breakline is modeled so it's a surface. Sometimes breakline is important when you make a feature a tin boundary. Maybe not. Let's see how it turns out. Okay, I forgot to click apply. Now let's try that again. There we go. And now the water is inside the dam, and if we calculate the volume, we don't need those features anymore. Oops. That feature will be removed. I better rename it. When the volume volume calculator works, if you have this checkbox turned on, it removes all the existing intersection features. So it's wise to change your intersection feature name to prevent that. I could have just turned that off. That would have done the same thing. Anyway, now there's a slightly different volume. It's gone down a little bit. It was 869 before. Now it's 862 because it's no longer over the edge of the dam. There's no cut at all. So this is all water volume. There's no overlap with that intersection feature. And there we go. Now I created an output sheet that illustrates how all this goes together, and I want to show that to you. I've created a bunch of files here. I created a file that represents the water. That's this one. I created a file that represents the dam by itself. I also created a file that is the merged surface of the dam and the original ground. And finally, I have the original ground. That was the first file I had. So to create an output sheet, you actually want all those in there. Well, not all of them. Let's take a look at my output sheet, which is just called dam. There it is. Now this is a slightly different dam, so the volume is slightly different. I created this earlier. And let's see how we put it together. So the plan window has two backgrounds, the original ground and the water. The foreground is the dam itself. So I've got three surfaces here, and the terrain window is showing all three surfaces. I made the water transparent. Let's see how I did that. So there's the water. By default, it shows up with this thing set to 255. That's the transparency alpha channel. So it would have looked like this. In your window options for the 3D window, each surface, there's the current surface, that's the dam, the background surface, that's the original ground, and the water surface, another background. You have all these options here for them. You can turn off the triangles and just display features. You shade. Most of the time, you don't want to see the triangles without shading, although if you don't shade, then the triangles are always transparent. If you do shade the triangles, they will be opaque by default. Of course, you can change the color here. And if you want to make a surface transparent, you just change this number here. I like 100. It seems to be a nice sort of level of transparency. It's proportional. 255 is fully opaque. 0 is completely invisible. So 100 is halfway-ish. And there it is. You can see through the water. You can see the ground underneath. And like I say, this dam is a little different from the one I just made, so the volume is a little bit different. Let's look at the section window. In here, all these things appear automatically in the section window, but they all look the same color until you go into the section background options, select the background, properties, and change the feature format here. So I changed the water to be blue, and I changed the original ground to have that line with all the dashes on it. And finally, more output. You can put this all into a multiplot. So here's a multiplot window. The 3D window, you kind of have to fiddle it like this. The plan window, you can set up the options so it doesn't scroll automatically, and then it will be locked into place. And then you can scroll it with the mouse, shift arrow, like so. Actually, I just turned auto on, and I meant to turn it off. But anyway, now that's locked into place. Similarly, the profile window can be locked into place, and you can set the station elevation so it doesn't move around. These windows you just create with the right click here. So for example, if I didn't have a profile window, I could say new profile. There it is, and then just move it around until I like the position. And I've got the grid turned on here. Snap to grid, 10 centimeter or 1 centimeter grid. So I can set that up. I didn't bother making a title block, but there's sort of a blank spot for me to put more information. That would just be a bunch of rectangles. Well, that went longer than I was expecting, so I'm going to kind of pause there and ask for questions. Now I see a few on the list here. Okay, we have a question. Can you grade just a portion of the line and use different slopes with transitions? Okay, so that's kind of the sort of functionality that we have in our location module. Clearly, you could just go over to the location module. If you wanted to grade the back of this dam to have different slopes at different places, you could certainly make an alignment along there and design it in our location module, and then you've got full template control, and you can do all kinds of things. The other thing you can do is break that into segments and grade them separately, and then kind of sew all the pieces together later. But the short answer to that question, can you grade different segments at different slopes, is no. The grading option here does not allow you to change the slope along the feature. So you have to make multiple features and grade them separately if you want to do that. When drawing features, how do you input exact lengths and angles? There's a good question. So I just happily clicked along here and created this thing. What if I had some prescribed location for the top of my dam? Well, it looks like the top of my dam is gone. I'll just create a new one here. Or maybe I'll open the demo. Let's open the demo. Right, so the top of my dam, I started with this feature here, and I just drew it with the mouse. But you don't have to just use the mouse. There is feature tools, coordinates. This allows you to type in XY coordinates. That's kind of tedious sometimes. You can also go into survey format, and now I can put in azimuth distance to generate my feature. So let's say I wanted to add a new segment at the end here. I think that's the end. Go into coordinates and survey format, and then add a new segment, and I can choose a distance, and I can choose an azimuth, and apply, add, update list. There we go. So there it is. And then I want to add a new one. It by default makes it the same length and the same azimuth, but of course I can change that. So yeah, that's one way you can draw in the terrain module and use exact distances and exact azimuths. Hope that answers your question. There's this question. Oh, I got a lot of questions here. I don't think I can answer them all. Can you copy and paste graded objects? Absolutely. Everything in terrain is copy and pasteable. So I can select here and copy to the clipboard, and then I can paste it somewhere else. So any one of these features, whether it's the boundary or the graded object, can be copied and pasted. And the second part of that question, yeah, you can if you're creating a bunch of pads, for example, you can take the top. I have an example here of a pad that looks pretty nice. But it's not on my recent list. Let's not waste too much time. Yeah, like if I had a square pad and I was building it here and I wanted to build a similar one over there, just copy, paste, and then move. So Control C, Control V, Control M, there, I've got another one which I could move over and build. Of course, it might not be the right elevation, and it's really easy to change elevation. Control M and then move with the mouse, or Shift, which allows you to type in a new coordinate for the current point, and you can also change the elevation there. and that moves the whole feature. Yeah. Now, the final question is, can we apply a grade to the a percent slope to a graded object? In my case, a pit floor for drainage. Yeah, I think that the simplest way to add drainage is just to put another feature in there. Generally, you would have. Let's just create a quick. Whoops. Let's just create a quick pit here. Keep hitting the wrong button. That's the one I want. So if I put the same old background in there, Quarry 2, okay, and zoom extents, there it is. Now actually this one already has a nicely designed pit in it. Let's make another one over here. I'm just going to make a square hole in the ground. So I'm going to do that by drawing a little rectangular feature. I'm not very good at drawing rectangles, so I'm just going to use the shape tool to make one. And the elevation of the ground here is about 1253. So let's use that feature I just showed you to set the elevation at 1250. So it's going to be about 3 meters deep. And then I'm going to grade it up to the surface. And it's going clockwise, so I'm grading left. I'm going to take all the defaults here. I'm not going to bother with volumes. There we go. There's my pit. Now that's flat. It's got well, there's no place to drain anyway, but I might dig a pipe out to the edge of the escarpment here. How would I make the bottom drain? Well, the way I would do it is I would create a new feature which is slightly below the level of the pit. And the pit is at 1250, so I'll make this at 12, whoopsie. This is a break line I'm creating. I'm going to draw it with the mouse, and we'll put it at 1249 point, I don't know. I'm just guessing here. Obviously, the width would be important because what's going to happen, you'll see, is that it grades down to this line. So I put the line in there. And again, if I had used my coordinates tool, I could put that exactly where I wanted it. Is this feature a break line? I don't think it matters anyway, whether it's a break line or not, because there's so many points along there. Okay, let's generate a surface. So right now, the triangles are going straight across. That's perfectly flat. And if I include this thing and regenerate my surface, now why did that not do anything that I wanted it to? Okay. I know why, because I forgot to click on that button there. There we go. So now it's got a slope going down to the bottom. If we look at that in 3D, you can actually see the slope. And the only problem is there's a flat spot right here. And there's a flat spot right there. So actually, to make this thing drain properly, I need to extend my break line or add new break line features that go to the corners, like so. The elevation doesn't matter because I'm going to snap onto there and snap onto there and snap onto there, and then regenerate my surface. And that will give me a nice drained, well, at least it'll drain to the middle here. And then it'll fill up with water if you don't put in a drain pipe. Okay, that's all I'm going to say for today. If you have any further questions, you can email us. You can also post questions after it's set up to YouTube. And there we go, that's better. Now that's got a nice sloping down trough. Okay, thanks so much, everybody.